should have section 3.1 here. We're going to go over one more problem from parabolas. We're going to go over it in several different ways and try and remind you of some of the things you can do. If you don't have a graphing calculator, you should probably borrow one. Now, can you tell me anything about this parabola as it stands? Just by looking at the form of this equation.
Go face down.
Yeah, it's going to open face down. Nice. In fact, there's one other thing that I would ask you for, and that's the y-intercept where the graph crosses the y-axis. Can anyone tell me where that would be? At 6. Nice. It's kind of nice because to find the y-intercept, you're just going to plug in x equals 0. But sometimes we want this equation in the form of f of x equals a times x minus h squared plus k. That is vertex form. What's the nice thing about this? Well, the nice thing about this is you can just look at this and determine what h and k is, that is the vertex. A is going to be the same either way. But let's see if we can't put this in vertex form. That's one of the skills that I'd like you to have coming out of this section. X squared minus 2x plus 6. Now, in order to put this in vertex form, we're going to have to complete the square. That's something I practiced with you the other day. So let's do it again here. The one problem that we have, though, is we've got this coefficient. That coefficient needs to be 1 in order to complete the square. So needs, that's not showing up too good, is it? Well, that's not too bad. It needs to be equal to 1 to complete the square. So, I need to get rid of this negative 1/2. And unfortunately, I can't add or subtract something from this equation in order to get rid of that. I can, however, multiply both sides by the reciprocal. What's the reciprocal of negative 1/2? Almost negative 2 over 1. So, or just negative 2. So if I do that, I get negative 2 times y. What's negative 2 times negative 1/2? 1. X squared. Negative 2 times negative 2 is a 4 plus, actually a minus 12. Minus 12. So, okay, that's looking a little bit better. We can complete the square on this part. Now, in order to be a perfect square trinomial, this number would have to be the square of half of this, and it's not. So what I'm going to do for the moment is just move this to the other side. When it changes sides, what else is going to change here? Its sign. Thank you. So negative 2y plus 12 equals x squared plus 4x. Now I'm in good shape. Now I can complete the square on that right-hand side. So let's see, I have a negative 2y plus 12 equals x squared plus 4x plus something. I don't know what that something is yet, but we'll figure it out. Now on the left-hand side, if I'm adding something to the right-hand side, I better add something to the left-hand side. So let me put a blank over there. So the number to be named later. Do you remember how to find this number here? What do we do there? Alex, remember that from?
Divided by half.
All right, divide which one by half?
4.
Yeah, so we're going to take half of the middle number. That's our first step. The second step, what are we going to do with that number? Square it. And that's going to give me a 4. So that 4 gets added in right here. And of course, if I add 4 to the right-hand side, what else do I got to do? Add 4 to the left-hand side. So great. We get negative 2y plus 16 equals x squared plus 4x plus 4. Now the right-hand side is exactly what I wanted. That's a perfect square trinomial. We just engineered it to be exactly what I needed. This is the square of a binomial. Please don't just put in a 2 here. 2 squared gives me 4. It doesn't give me the rest of this. What's the complete binomial here? What do I need? Brooks, what's going to go in there? Plus or minus? Yeah, plus. It has to be plus because everything is positive. Great. Now I need to solve for y. So let me move the 16 back to the other side. Negative 2y equals x plus 2 squared minus 16. And let's come up here. I don't quite have y solved for, but it's not too hard to finish solving for y. So, Jess, what do I do to solve for y? Yeah, divide by negative 2. You could also think of multiplying by negative 1/2. So negative 1/2 on both sides. So that's going to put that negative 1/2 back where it started. That's okay. Negative 1/2 times negative 2 is going to give me a y, a 1y. The negative 1/2 is going to stay out in front here. So let me just kind of keep that there. Negative 1/2 x plus 2 squared. Negative 1/2 times negative 16 gives me what? Positive 8. There you go. Thanks, Tony. So looking at this, this is in vertex form. That's what I wanted. You can look at this, and I hope you can look at this, and read off what the vertex is. So, Chloe, help me out here. What would the vertex be? Start with the squared part. Good. If you plug in a negative 2 here, this whole term disappears as a 0, and you're left with an 8. So negative 2 and 8. Beautiful. Now, is there a faster way to get here? I'd say so. Yeah. Let me remind you from the other day, at least I think we did it the other day. If you have a formula like y equals ax squared plus bx plus c, that's going to be a parabola. The x-coordinate of the vertex is x equals negative b over 2a. So let's take a look at what that's going to mean for us here. We've got negative 1/2 x squared minus 2x plus 6. What are a and b in this particular case? All right, so it's going to be the negative of negative 2. Good. Negative 2, that's our b. What's a? Thank you, Annalise. Negative 1/2. Negative of negative 2 gives me 2 over negative 1, which gives me negative 1. That's the x-coordinate of my vertex. How about negative 2 there? I was looking back at that. I'm wait a minute, that doesn't look right. All right, negative 2. And that's pretty cool because it matches what we had on the first page. How am I going to find the y-coordinate though? What do I do to find the y? I found the x-coordinate of the vertex. How am I going to find the y-coordinate?
Plug in the x.
Yeah, plug in the x. If you want the y-coordinate, just plug in the x. Thank you. So negative 1/2 times negative 2 squared minus 2 times negative 2 plus 6. So just plugging in this guy right here. And when you grind it all out, shocker, shocker, you're going to get an 8. So great. Now we've got an 8 here. In fact, we know our vertex. So our vertex is negative 2 and 8. That's your h and k in the formula y equals a times x minus h squared plus k. Where am I going to get my a? Alex?
Negative 1/2.
Yeah, it's just negative 1/2, right? That a is already there. So this a, that's your a, negative 1/2. So plugging this stuff in, I've got y equals negative 1/2 times x minus negative 2 squared plus 8. Or better yet, negative 1/2 times x plus 2 squared plus 8.
I might be just going crazy, but the equation up there was like we plugged in -2. It kind of looks like it would equal 11.
Let's see, when we square that out, we get 4 times negative 1/2 is going to be a negative 2. Okay. All right, no worries. Appreciate you checking me, though. Thank you. All right. So that's a second way that you can get this equation into this form. What's the advantage of having it in that form? Well, the advantage of having that form is you can tell what the vertex is, and you can graph it. In fact, let's see about graphing this. Find some key points for this polynomial. And let's see. So we're going to graph y equals negative 1/2 x squared minus 2x plus 6. That's also equal to negative 1/2 times x plus 2 squared plus 8. So you're free to choose either one of these. It just kind of depends on what you find most interesting or most helpful. Let's set ourselves up a little t-table here and graph some points. We know what the vertex is based on this formula right here, x and y. The vertex is going to be negative 2 and 8. Now to find the y-intercept, we already did that. You're going to set x equal to 0. It's easier to set x equal to 0 over here, because this term and this term just disappear, so you get 0 and 6. What about finding the x-intercepts? What do I have to do to find the x-intercepts?
Change the y to 0.
Yes, change the y to 0. So x-intercepts, we're going to set y equal to 0. Now you've got two choices of where to do that. You can do it here or you can do it here. If you do it here, you're going to end up needing the quadratic formula. So let me remind you about that one. I'm hoping that that's something that you have firmly in mind, but if you need a quick look at it, negative b plus or minus the square root of b squared minus 4ac over 2a. And if needed, you can Google it, quadratic formula, and pop goes the weasel, and they will sing it to you. And that'll just be permanently etched in your brain. So if that works, great. But I'm going to set x equal to 0 here, because we've already completed the square, and it's just going to be a little bit more user-friendly for us, I think. So let's see about solving things here. So we'll set 0 equal to negative 1/2 times x plus 2 squared. 2 squared plus 8. You remember what happens when we move something from one side of an equation to another side? What happens to that term? Changes signs. I want to get rid of that negative 1/2. That's kind of a pain here. You could move the 8 and then, get rid of the negatives that way. But if I just move this whole term to the left-hand side, I'll get 1/2 times x plus 2 squared equals 8. And that's a little bit nicer because now I don't have any negatives. Suggestions. What would you do next in order to come up with a solution here? What's a nice next step? Thank you. No, it's okay. Appreciate both of you. Multiply by 2. So multiply by 2. That works out pretty nice. You get x plus 2 squared equals 16. So now what? Square root. Excellent. Square root both sides. What mistake am I making?
Plus or minus.
Yeah, you need that plus or minus. There's two solutions here. So you need that plus or minus. So let's see. Let's come over here. There's two possibilities. And we want to get both of them. There's the positive case, x plus 2 equals positive 4. There's the negative case, x plus 2 equals negative 4. X equals 2, x equals negative 6. Nice. So 0 for y goes with 2 and negative 6. You're not always going to get nice, neat points like this. Sometimes you're going to get things that involve a square root. That's okay. Let's graph this. Let's see. Something like yeah, I didn't give myself enough room. Bummer. Two, 4, 6. Okay, maybe I did give enough room, but barely. All right, so let's start with the vertex. The vertex is at negative 2 and 8, so that's all the way up here. And then you've got x-intercepts. One of them, no, let's see, we got a y-intercept we'll do next, 0 and 6, which would be up here. X-intercept at 2, 0 and negative 6, 0. So we'll play connect the dots for all the stuff in between. There, and pardon me any vertigo or anything like that. Nice. Through the vertex goes an axis of symmetry. Let's make sure that our graph looks symmetric, at least to within the limits of my drawing ability. The thing that I look for is this. From our center line, 1, 2, 3, 4 to the right, I've got an x-intercept. 1, 2, 3, 4 to the left, I've got an x-intercept. So it's looking pretty good. If it was off kilter, then check things. Sometimes you plotted it wrong, maybe sometimes you made a calculation wrong. But this is a nice double check of your work when you're all done. All right. There's one last thing we can do here to try and make some of your life a little bit easier. If all you need to do is put this in this form, then what you need to do is you need to find the vertex. You can get that off your graph. Did I show you how to do that the other day? Off the graphing calculator? Let's do that. Let's nail it. So let's put that equation into our graphing calculator. By the way, graphing calculator is a nice way to double check your work too. So let's clear out some stuff that's here. As far as the negative 1/2 is concerned, I'll type it in as negative 0.5 x squared minus 2x plus 6. Looking good. Now, a lot of times when you're graphing these things, you don't know where to graph them. But in this case, kind of do. So maybe I'll graph it from, say, negative 8 to 4 or something like that on the x-axis, and then negative 2 to 9 on the y-axis. That should fill up the frame pretty nicely. I generally like to have a little room on either side of my graph just to kind of see what's happening. And that's what I'm giving myself with these coordinates. Negative 2. I also like seeing the axes when possible. And let's, for giggles, make x, y scale I'll make it 2 or something like that, just so that we don't have as much busyness going on. And bam, looking pretty good. Now if you're doing this at home and you're like, all right, I just need the vertex, you can kind of eyeball the vertex here, right? -2 and 8. Are you up with me this far? Now there's 2 more little things that I can do. If you're unsure, if you're like, is that really, so I don't know, it's kind of flat there, you're not really sure. One quick way is to hit the trace key. If you hit the trace key, it should put a cursor on your graph right in the middle of your graph. And right now I'm getting -2 and 8. That's great. If you have another circumstance, you can do a little bit of work here to find the maximum or minimum of your graph. You can hit the second key, then the calc key. This is what do you want? Well, I want to find where, in this case, we have a maximum. And it's going to ask you, where should I look? So you're going to give it a left bound. So cursor over a little bit to the left of where you think your maximum is. Press the enter key. Cursor to the right. Press the enter key. And then press the enter key one more time, and it'll come up with your maximum. Now, take a look here. We got -2.001. So it's coming up with a little rounding error. That's because your calculator can't do things exactly the way we can. But if you got this, what would be your assumptions? Like, okay, it had some rounding error. The real point is -2. Yeah. Okay. Nice. How are we looking on this one? We did this one several different ways. So all of them work. The bottom line, though, is to expect a couple things from me. One of them, I'll just ask you an equation. I'll give you an equation, something like this, or maybe a little easier, maybe a little, it's not really going to get any harder. And ask you to write it in vertex form. That's going to be its own problem. Another thing that I'll do is I'll give you both forms of this equation and ask you to graph it. And I'm going to want to see these points. Don't count on getting nice even points like this, all right? This is college algebra, not intermediate algebra. These points are going to get a little bit harder, so expect something with a square root, etc. If you end up with something with a square root, then the trick is, like in this one that you see in an extended version of the notes, with this one, we ended up with 8 plus the square root of 5. I don't know where that is in terms of graphing, so take out a calculator. Get a decimal value. All right. Actually, I think these are reversed. Now that I look at it, this should be the 9.3 and this should be the 6.7. So, in any case, you can take out a calculator and figure out roughly what those values should be. All right. Any other comments or thoughts on parabolas here? You feeling comfortable with these? A little bit better moving forward? Ben?
So for finding the vertex, will we have to use the perfect square method? Or?
So there's a lot of choices here, right? I mean, if you can get a good enough graph, then you can find the vertex from the graph and then do it that way. If the graph, you know, if I choose some really crazy numbers and you're having a real hard time getting the graph, then what's your option? Well, then you can use this formula, right? So once you find the x-coordinate, plug it in and find the y-coordinate. So nothing wrong with that. So you've got a lot of different tools that you can use, and it's just going to depend on the problem, what's most convenient. All right. I generally don't dictate you have to do it this way. I like to give you lots of options and do whatever works. Okay. Appreciate the question. Thank you. Anything else? All right. Good session.